Hello, Mr. Liao. Welcome to our boat project by Bill John Conway. So this is our boat. As you can see, the hull is just a plastic Tupperware with some coins in the center to serve as a weight to weigh down the boat. The propulsion mechanism comes from two propellers that are powered by two wound up rubber bands. So these are the dimensions of our boat. So this is how we calculate water level. We essentially knew that the force of buoyancy was equal to the force of gravity. So first we calculate the force of gravity, and then we got that was the weight of the boat, which is about 7.566 newtons. We then set that equal to the force of buoyancy, which is equal to the density of water, or 1,000 kilograms per meter cubed. We then multiply that by meter cubed times the acceleration of gravity times the water volume displaced water. We got the volume displaced water and divided that by the total volume of the boat. And that got a ratio of the volumes. Once we did that, we multiplied that by the height of the boat, and we got the height was around 2.05 centimeters. And we marked out the orange line. As you can see, it matches almost perfectly with the water level. So this is our how we calculate our kinetic energy, potential energy. So essentially, we knew that our potential and kinetic energy would be equal to torque, and our torque would be equal to force times the radius of the propeller. So we got the force by allowing the propeller to spin against the scale, and then the scale would essentially read the force sharing propeller. Once we found that, we could find the torque as we knew the radius of the propeller, and after that, to find the energy, we just essentially integrated torque with respect to angular displacement. And we got around, because we had two propellers, we did multiply our integral by 2, around 0.381 joules for both the potential and theoretical kinetic energy. So our K effective, we didn't really have one because our rubber bands K constant is constantly changing, and we knew that our boat lost energy. So in order to figure out how much energy lost, we first had to figure out the distance travel, which was about 0.91 meters. We then divided by the time it took for the boat to travel, which is about 13 seconds to get with the average velocity. Once you did that, we plugged that into the kinetic energy formula with 1/2 mv squared, and we got about 0.00189 joules. That was so then we check the potential energy to get the total amount of energy lost as up 0.3795 joules.
So this is our boat, and as you can see, it's powered by two rubber bands and two propellers at the back.